All right, so we're going to continue our journey to simplify rational expressions. Previously, we did multiplication and division. Today, we're going to focus on adding and subtracting, and we're going to try to keep it pretty simple today. We'll go into some more complicated ones in the next lesson. Okay, so first, I want you to just take a moment and think about which of these statements is true. What do we need to do in order to add fractions? So if you need to pause the video and take a minute to think. All right, so if it's not ringing a bell for you, something that you should always have in mind when you're adding and subtracting fractions is the need for a common denominator. So unlike multiplication and division, where you can just multiply across the top and the bottom, you can't just add across the top and the bottom for addition. So you are not going to be adding the numerator and the denominator. Instead, what you're going to do is get a common denominator, and you're going to add the numerators and keep the denominators the same. Okay, this should make sense when you're thinking about simple fractions like 1/2 plus 1/2 does not equal 2/4, because that would be 1/2 again, right? 1/2 plus 1/2 equals 2/2 or a whole. So you add across the numerator, you keep the denominator the same, but the denominators have to match before you can do that. So the first thing you want to do is figure out your least common denominator. So you're going to be thinking about all the multiples of your denominators and come up with the lowest one. So 6 and 7. Let's see. The lowest number that I can think of that is divisible by both 6 and 7 is 42. So in order to make these denominators both 42, I'm going to multiply the left one by 7, and I've got to do that on the top and the bottom. And I'm going to multiply the right one by 6 on the top and the bottom. So that on each bottom one, I get 42. All right. Why am I multiplying by the top and the bottom? 7 over 7 is just 1. So this is multiplying by a clever form of 1. If you're multiplying by 1, you're not changing the value of the fraction. So we're not changing what's happening here. We're just changing the way that it's written. So this is going to give me 35 on the top over 42 on the bottom, and 36 on the top here over 42 on the bottom. And then we add the numerators. So we're going to get 71, and we keep the denominator the same, 71 over 42. Okay, so in this case, the least common denominator just happened to be 6 and 7 multiplied together. Okay, that's not always going to give you the lowest or the least common denominator, though. For example, in number 2, if I take 2 times 6, that's 12. I can get a common denominator of 12, but that's not the least common denominator. That's not the lowest one I could do. Okay, 2 and 6 are both divisible by 6. So I don't need to go all the way to 12. I can actually leave the second fraction alone. I can multiply the first fraction by 3 over 3, 3/6 minus 5/6, and they have a common denominator. That's going to give me -2 over 6, which is -1/3. You can always simplify your final answer if possible. Oops, that's not where the final answer goes. The least common denominator was 6. Here's my final answer. Okay. Now you could have x's in your denominators. Okay, let's think about just the 2 and the 3 first. The smallest number that is divisible by both 2 and 3, you can always look at factors lists if you need to, but the smallest number that's divisible by both 2 and 3 is 6. And then both denominators also have an x. So that's part of my lowest common denominator. And I need to make both of those denominators then be 6x. So the first one already has the x, and it's got a 2. To make it 6x, I need to multiply by 3. And for the second one, I need to multiply by 2. So I'll get 3 over 2x. I'm sorry, 3 over 6x. plus 2 over 6x is 5 over 6x. Very similar for the fourth one. The smallest number that can be divided by both 2 and 5 happens to be 10, which is 2 times 5. But at least one of those denominators has an x, so they need to both have an x to make them the same. So the first fraction, I'll just multiply by 5 to get the 10x on the bottom. But the second fraction, I'm going to have to multiply by 2 and x. Because 5 times 2 will give me 10, but I need to also have that x in the denominator. I'll get 5 over 10x minus 2x over 10x. And I can put this together in one fraction, but I can't do anything else to simplify that numerator because 5 and 2x are not like terms. Okay. So we kind of gradually increased the difficulty here, and now we're getting closer to the types of problems that we're going to be focused on in this standard. So let's take it up another notch. All right, I want to figure out my lowest common denominator. It would be so nice if I could just add 2 to the numerator and the denominator. But if you add something to the top and the bottom, you are changing the value of the fraction. So for example, let's say I had 1/4 and I added 2. Let's make it something different. Let's do 3. Let's say I added 3. No, let's do 2. I like 2 better. All right. I've got 1/4, and let's say I add 2 to the top and the bottom. That's going to give me 2/6, which reduces to 1/3. 1/4 is not the same as 1/3. And we can't change the value of this fraction. So we can't just add 2 to the top and the bottom to make these equal. So if I want to make these denominators the same, I'm going to have to multiply by something. Okay, well, when in doubt, just take both of the denominators and put them together as one. So I need to multiply the x and the x plus 2. That's the only way I'm going to be able to do this. So I'm going to have to multiply the first fraction by x plus 2 on the top and the bottom, and multiply the second fraction by x on the top and the bottom. So in the left fraction, I just get x plus 2, because 1 times x plus 2 is x plus 2. And on the bottom, you don't need to distribute. You can leave the denominator in factored form, or you can distribute. It doesn't matter. On the second fraction, 1 times x is x. We've got x times x plus 2. Now the denominators are the same. They're both x times x plus 2. So I can add up my numerators, x plus 2 plus x, and I'm going to keep the denominator the same, x times x plus 2. You can leave the denominator in factored form, but on the top, I do have some like terms that I can combine. The x and the x makes 2x. And then we can go ahead and stop there. Let's do another one, okay? I've got x and x squared. Now I could multiply those together and get x to the third, but I can actually go a little bit lower than that. In the last one, I couldn't add 2 to both sides, to both the top and the bottom to make them equal, but there is something I can multiply the first fraction by to make the denominator the same as the second fraction. If I just multiply the top and the bottom by x, I'm going to get x squared in the denominator. So I don't need to multiply the second fraction by anything. The first fraction, I'm going to get x over x squared. Second fraction is 3 over x squared. And now that the denominators are the same, I can add the numerators together and keep the denominator. X and 3 are not like terms, so I'm done. All right. Here's another one. I can't change what's added or subtracted to the top and bottom. So I'm going to have to multiply these two things together to get my lowest common denominator. So I'm going to have to multiply the first fraction by x plus 1 on the top and the bottom. And I'm going to have to multiply the second fraction by x minus 1 on the top and the bottom. Okay, and notice that this one is subtraction, so we'll have to pay close attention to that in a minute. All right, and that first fraction, I'm just going to get x plus 1, and then my denominator, x plus 1 times x minus 1, minus my second fraction, it's going to be x squared minus x over x plus 1 times x minus 1. Okay. And when I subtract, I need to make sure that I subtract both of these things. So I'm going to have x plus 1 minus x squared minus a negative x all over x plus 1 times x minus 1. Now, subtracting a negative is the same thing as adding. So I'm going to combine all my like terms. X plus x is 2x plus 1 minus x squared. The order that you write those things in on top does not matter. You don't have to FOIL the bottom. You can leave the denominator the same. We just want to simplify the numerator as much as possible.